talk about. Is there any like initial questions that you guys have or anything? Okay. So before I begin, I want to address something that kind of brought to my attention about Module 8. Um, and it has to do with this chart. This chart. Okay. This chart is not really like properly accurate, in my opinion, right? So delta G naught is a standardized number, right? This number correlates to something that's like the delta G value at 25 degrees Celsius and at a certain pressure, right? And
Sorry
the same,
for
yeah.
interrupting. Are you sharing your screen? I can't see it.
Oh, I'm not sharing my screen. Thanks for letting me know.
You're welcome.
That would have been really awkward. Um, okay. Anyways, so this chart here, there's a little bit of, I guess, errors that I would say with this chart, right? So I was saying here that delta G naught, right? That represents a value at 25 degrees Celsius and at like 1 ATM specifically. But like for a specific general reaction, if you want to know if something's at equilibrium, the delta G naught value is not really, it's not indicative of if it's at equilibrium. What actually is like the value at equilibrium or like whichever one is the literal like delta G value. So there's a difference between delta G and delta G naught. And the same thing is also true for E cell and then E cell naught, right? So like all these, if I go up here, all of these values here, these are E cell naught values, right? And they're given at a specific temperature and pressure, right? And concentration. But E cell like regular is like the actual general like reaction thing, right? And so these values here, they shouldn't be E naught or E cell. They really should be just delta G and like E cell, like without the naught. And when it comes to the K value here, one thing I would say here is this is also kind of incorrect too, right? K is a constant, right? So if K is equal to one, like that doesn't tell you if the thing is at equilibrium or not. It just tells you the ratio between the products and reactants at equilibrium. The same applies with like if K is greater than one, right? We talked about this in module 4. That correlates to there being more products than reactants, right? So like I don't really like this chart because it's not proper in showing when is something at equilibrium. What's I guess more important is like, yeah, the way Q and K represent one another. So if Q is less than K, that means there's more reactants than products. And so the forward reaction is going to be favored. If Q is greater than K, right, that means there's more products than reactants. So the reverse reaction is favored. And then if Q is equal to K, that's how you know things are at equilibrium. Okay, so I just wanted to clarify this because I don't think this chart is correct in the way that it's, illustrating these points about spontaneity and equilibrium. But does anyone have any questions about this? Okay. All right. Yeah, there are questions on the practice exam that's related to this. So yeah, um, we'll go over this. But the big idea is like definitely the Q and K values, and then just make sure that these aren't not values, not refers to this degree sign. But yeah, okay. All righty. So I'm gonna give you guys, um, I'd say approximately 8 minutes to try to do these first page. I'll give you guys, yeah, till 2:19 to do it. If you guys have any questions, just feel free to shout it out to me because I can't see it. But yeah, we're gonna just go through this first page. Um, so yeah, 2:19, we'll get back together.
Luke,
Yeah,
when we do go over it, can you just like for all the problems, can you like if it's possible, write out the equation for like everything and like the balanced out equation? Because like I feel like I always struggle like like starting that and like writing it out. And I never know like, you know, but yeah.
Yeah. Yeah. We'll I'll do that. Alrighty. So let's go over some of these. So for number one, the first, yeah, the largest entropy change would have the one that's, this is based off like, I guess like determining entropy in general. So like for these kind of questions, like the ones with the greatest number of gas moles, in comparison to the reactants would be the greatest entropy change. So for one, that would not be right. This is supposed to have gas moles in A, but still that would not be good. It's going from a gas to a solid basically. From B, we have 5 moles of gas on the left and 4 moles of gas on the right. So that's also not super great. C, we have solid going and forming 3 moles of gas. So that's pretty high entropy change. Uh, D, you're going from 3 moles of gas to 2 moles of gas. So it's not that high. And then the last one, you have 3 moles of gas also forming 3 moles of gas. I really forgot to put a lot of these states of matter, but yeah, the answer choice in this case would be C. Okay. For two, the Bronsted-Lowry acid base definition. So this is such a weird sentence. What is the conjugate base of like oxalic acid's conjugate base? Um, but it's basically just what is the conjugate base of the acid. So as you know, Bronsted-Lowry acid base definition, right? The conjugate acid is, or the conjugate base would have one less hydrogen. So the answer choice here would be choice B. Okay. Yeah. Uh, yeah. What is the pH of a 0.350 molarity of barium hydroxide? And so this is a strong base. We know this because it's ionic. And so in order to figure this out, we would have to do 14 minus the negative log of the concentration of hydroxide. Okay. And so for this case, for every 1 mole of barium hydroxide, there's 2 moles of hydroxide. So in order to get the proper concentration, you need to multiply this by 2. So that would be 0.700 molarity. And so when I do this on the calculator, um, I get, let me pull up my calculator. I need to put batteries in my calculator. Um, Calculator. So 14 minus the negative log of 0.7. And I got D as the answer. Okay. All right. For four, we have this coordination complex, and we're asked to figure out. Yeah, it tells you there's two different arrangements of ligands. Um, and yeah, they're kind of yapping, has different colors, but then the question is like which one's acting as a loose base. And so typically the central atom is always going to be like the loose acid, and things around it are going to be loose bases. And so we see that there's ammonia and there's chloride. So those two things are going to act as bases. So the answer choice is E. You could also draw out the structures for ammonia and chloride, and you see like they have a lot of lone pairs, right? Whereas cobalt is Co plus, probably just plus in this case, um, or plus two. Yeah, probably plus two or plus three. I don't really know. It's some plus number, but still. Okay. Number five to seven is based off these different concentrations and or these different solvents and solutes. So what's the strongest interlocking force that's found in solution A? Solution A has methyl chloride and water. So the highest thing there would be dipole-dipole because within the water, it's hydrogen bonding. And then within the methyl chloride, it's dipole-dipole. And so the highest thing, hydrogen bonding is a type of dipole. So C would be the answer there. All right. The boiling point of ammonia is negative 33. What is the boiling point for D? So D has ammonia and phosphine. So this is based off colligative properties. In colligative properties, boiling point increases and freezing point decreases. And so because it's negative, you want to make sure you pick the right answer. So boiling point would increase. So the answer choice would be A. Yeah. 7, compared to pure water, solution C has. Solution C is just a solution with a salt, potassium nitrate. So it's going to have, this is based off positional entropy, right? Um, or just like the fact that like one of the things like solutions are more and like higher entropy than pure substances. So C, A, B, and C are right. Um, and then yeah, it would have a lower freezing point and it would have a lower vapor pressure because as intermolecular forces increase, you have a decrease in vapor pressure. So the answer choice there would be B. Okay. And number 8, which of the following include indicate systems at equilibrium? So you can see here how what I said there on the from the chart over here is being applied to here. Delta G is not, it's not delta G with a not sign, it's just delta G. And so we know that this is equilibrium. We also know that this is equilibrium. So the answer choice there would be B. All these other states show that one reaction is being favored over the other. All right. Any questions regarding this? This is pretty much, most of these questions were all conceptual. So make sure you are able to answer the questions properly. Yeah,
I
is there
had a
any,
question
yeah,
for 5.
for 5. Yeah, what's up?
So, does the electronegative atom have to be in the species that's bonding with the hydrogen as well as the other species that's going to have the intermolecular force?
Uh,
Like for it to be considered a hydrogen bond?
so like if the methyl chloride had like, let's say it was like if if instead of it being methyl chloride it was a NH3, or
Mhm.
let's say it was CH3CO8 or like methanol, that would indicate that there would be hydrogen bonding because it has to also be bound to oxygen, nitrogen, or fluorine.
So they both have to have hydrogen bonds in both of them?
Yeah,
Okay.
yeah. If instead of it being like water, let's say instead it was like ethane. Ethane is C2H6, right? The highest like intermolecular force between the two would just be dispersion because ethane is highest thing is only dispersion. Whereas like methyl chloride has dispersion and dipole. Does that make
Wait,
sense?
you're saying that if the water instead was the ethane, but
Mhm.
isn't there still like the chlorine on the other one? So wouldn't it be like a dipole or something or no? Like
It would be a dipole between the solute molecules, but between the solute and solvent, which is what it's saying in the question, it would only be dispersion.
yeah, but doesn't like the Cl like bond with like one of the H's or no?
With like ethane, with like hydrocarbons, they're generally like super nonpolar. So even though there might be some bonding with the chlorine, like it's not going to be a dipole-dipole bond because dipole-dipole requires two dipoles. The hydrogen is not a dipole on like a hydrocarbon.
Okay, thank you.
Yeah, no problem. Jennifer, are you all good with whatever questions you were asked?
Mhm. Wait, I
Okay.
just want to ask, so does it have to have the hydrogen bond specifically in both of them, or does it just have to be like the other one can have something electronegative? Like, do you know what I
And
mean?
it has to have the hydrogen bond in both of
Okay.
them. Yeah.
Okay, got it.
Mhm. Any other questions? Okay. All right. So do you guys want me to give you guys time to do the question, or would you guys rather me just go over everything?
Time, please.
Please what? Give you
Time
time?
to like, yeah, to do it.
Okay, yeah, I'll give you guys some time. So we got 9 to 17. So I'll give you guys probably 10 minutes to do these. So at around 2:40, we'll go over it.
Luke,
Yeah.
I already did the test, but I had like two questions. It's like 20 and 21 that I had like specific questions on. So can I just go over that really quick and then I'll probably just go back and watch like your YouTube video?
Um, okay, we can go over it quickly. So 20 and 21. Um, what's it called?
I was like
Hmm,
first up struggling like on how to like write the equation for like the ice chart because I knew it had to be like an ice chart, but I didn't know like whether to like include like I never know where like the salt should go in the equation, like if it should go on like the left or right side. Like I just like didn't know what to do.
Mm-hmm. Um, what's it called? Mm-mm-mm. If it's okay, Zoya, would you be able to wait for me to go get to this part? Because I don't want to like re-explain it twice.
Wait, no, that's fine.
Is
But
that okay?
when you do go over it, can you just like
Hmm.
explain like the equation part of it?
Yeah, yeah. I'll
And
explain
like,
everything. Yeah.
okay, thank you.
No problem. Sorry for that. I want to keep everyone together with that. But yeah. Okay. Hi guys. Um, yeah, so we'll go over 9 to 17 now. So number 9, we're given this acid, and when they give you a Ka value, that tells you it's a weak acid, right? And so this is 3-chlorobenzoic acid. The question is, what intermolecular forces are going to arise on this sample? So we have hydrogen bonding, and hydrogen bonding is a dipole-dipole, but we also have the chloride, so that's also dipole-dipole. And it has dispersion forces because it's a compound. So answer choice here would be choice E. What is the volume when this strong acid or strong base is reacted with this amount of acid? And so what you want to do here is anytime you see, even though this is a weak acid, this is a simple neutralization question. All neutralization questions are all the same, regardless of if it's a weak acid, strong base, or strong base, strong acid, or weak base, strong acid, right? The whole idea with this is that H plus needs to be equal to OH minus. Not just the concentration, but specifically the moles. The moles of OH minus need to equal the moles of OH minus. So why is that important? When we do this question, we need to figure out the moles of benzoic acid that's being produced, right? So we use 1.75 liters times the molarity, which is 0.0330. And this is a mole over liter. And what's it called? For after we do this, right, for every 1 mole of this acid, right, we're going to be producing 1 mole of H plus. And so this will equal the H plus concentration. So let's do that. 1.75 times 0.033. And we get some value of 0.05775. Okay. And that's moles of H plus. So after we do that, that's also the moles of OH minus, right? And so for every 1 mole of OH minus, we have 1 mole of KOH. And then we can flip the molarity, right? So 0.15 mole of KOH over 1 liter to get the volume. So let's do that. 0.150. And I got 385 liters or 0.35 liter or 0.385 liters or 385 liters. So the big idea with this is that H plus equals OH minus. Is there any questions with 10? Okay, so that was a neutralization question. The next question is kind of a titration, right? So this is similar to the question that you guys had on your exam, on the second exam. But when a weak acid is titrated with a strong base, right? Regardless of the concentrations or whatever, at the equivalence point, weak acid, strong base titration. This is based off the graph, so you need to make sure you remember this. But the answer choice would be C, greater than 7. That's because at the equivalence point, you're going to have the conjugate base left over, which causes the pH to increase higher than 7. And then 12, what is the pH of a solution when this solution is titrated with this amount of KOH? Here, this is where we're going to do a ICF chart. So we have a weak acid reacting with a strong base. So KOH times HA or plus HA, right, yields A minus plus, sorry, it would be Ka, which is like A minus, right, plus H2O. Okay, so we're going to do an ICF chart with this. And the reason why I could see this is because we have a strong base reacting with the weak acid. And so we have to find the moles of all of them. So 0.110 times 0.15. This is the moles of KOH here. And we have the moles of acid up there, 0.00330. 0.05775. And we don't have anything here yet. Water doesn't matter, right? So this is 0. So we're going to subtract 0.05775 by 0.0165. And this is going to be 0.0165, 0.0165 mole here. And here it's going to be 0.04125. So we're subtracting here. And then this cancels out, right? So that's left over. So now we have weak acid, its conjugate base, and we have the Ka value given up there. And so what we can do here is we have to find the concentration of HA and A minus, and then we can plug it into Henderson-Hasselbalch to figure out the pH. So let's do that. 110 milliliters plus 1.75 liters. So okay, so we're gonna have to divide this by 1.86 liters on both sides. So let's do that. And so we'll do it here. So if this value here, I got 0.0221. I'm just gonna plug it into the calculator after I do this, right? Here it's gonna be 0.0088. And then now we're gonna plug it into pH is equal to pK plus log of base over acid, right? So let me plug these values in. So negative log of the Ka value, so 1.10 times 10 to the negative 4 plus log of base. The base would be, where is it? Base would be this value divided by weak acid, which is this value. And ultimately, I got choice B as the answer. So I went through that really slowly with you guys, but when you do it on the exam, don't try your best to, try to go faster than how I'm doing it. Make sure you recognize what you have and yeah, work at it fast. Does anyone have any questions about 12? Okay. So yeah, the big idea is first you do ICF when you realize the weak acid is titrating with a strong base. And after that, you do Henderson-Hasselbalch because this, you can see that KOH doesn't, it runs out. Alrighty. Let me move this up a bit. Let me shrink this. Okay. 13. Which of the following copper 2 compounds is/are expected to be more soluble in an acidic solution than in pure water? So this idea is you want to make sure that you identify which ones are conjugate bases of weak acids. So this is based off the concept of weak acid, strong base, or the weaker the acid, the stronger the conjugate base. The weaker the base, the weaker the acid, the stronger the stronger the acid, the weaker the conjugate base. So we know that OH minus is a pretty strong conjugate base, and we also know that SO3 minus is a strong conjugate base. And so yeah, the answer choice here would be choice 2 and 4. Br is a conjugate base of a strong acid, and NO3 is a conjugate base of a strong acid. Okay, so all right, with number 14, we have this equilibrium for these concentrations for cadmium and ammonia. And they're asking what's the concentration of this complex. And they give you the KF, right? So the KF is the formation of the complex. So you have to write out the formula. So NH3 plus Cd plus 2. And this yields Cd, the form, like the complex, right? Okay. And so we don't need to do an ice chart I just wrote out this formula for our sake. But what we need to do after this is we need to plug in the values. So Kf is equal to product over reactants. So CD NH3, right? 4 plus 2, the concentration of that over NH3, 4, and then CD right there, right? And so we need to plug in the values and then figure out what this is, the complex. So it's essentially KF times NH3, the fourth power, and then times BD plus 2. So let's do that. So 1.30 times 10 to the 7 times 2.75 times 10 to the -2 to the fourth power times 1.55 times 10 to the -2. And I got a value of choice B. And does that make sense? Yes, it does. It does make a lot of sense because KF is a really high, big number. So yeah, I mean, all these numbers are pretty big except A, but B makes like the most sense, I guess. But yeah. Any questions about that? Okay. All right, let's go over 15 to 17. So 15 to 17 is an exothermic reaction, and it's first order with respect to O3, and it's second order overall. So if it's first order with respect to O3, that means this is also first order, because it tells you it's overall second order. But anyways, we can also see here that, or before I do that, question 15 asks about the spontaneity. And so we can see here that it's going from 2 moles of gas on the left to 3 moles of gas on the right. So there's a positive delta S value. And because it's exothermic, we have a negative delta H value. And so this means that this would be spontaneous at all temperatures, which is why C is the right answer. Okay. Next question. What is the rate law? The rate law is second order. And I mean, all of these are not second order, but the second thing is that it tells you that the O3 is first order. So that has to imply that ClO is second order, or is first order as well, because it's second order overall. Okay. And then using the thermodynamic information, what is delta G naught, right? And so we can figure that out by plugging in values. So products minus reactants, so 2 oxygen O2. So delta H for this case would be 2 times 0 plus BL, or where's CL? BL gas. So that would be choice here, 121.3 minus what is O3. So O3 is 142. Okay. 142.7 minus or plus ClO, so 131. Okay, so let's do that. So 121.3 minus 142.7 plus 131.2. And I got a negative 152.6 kJ. Now delta S is the same process where now we're going to do 205.2 plus 205.2 times 2 plus 165.3 or 2 or minus O3, which is 238.9 plus 309.2. So let's figure this out. So 205.2 times 2 is 165.2. Okay, minus 238.9 plus 309.2. Okay. And so I got a delta S value of 27.5. So it should be 0.0275. And then we plug it into delta G naught is equal to delta H minus T delta S. And T is going to be 298.15. And you plug in the values accordingly, right? Yeah, and then you should get your answer. So negative for this value minus 398.15 times 0.0275. Yeah, and I got choice. That's choice C. Okay. So the big thing in here is just making sure you remember products minus reactants and everything like that. Is there any questions regarding any of these questions? Okay. I'm gonna move on. So we got 3 more pages. Okay, so I'm gonna give you guys I guess 10 minutes to go over these next few questions. All right. Yeah, let me know if you have any questions. Okay, let's go over some of these questions. So number 18, yeah, so we have calcium hydroxide and we have the concentration there. And so they're asking to find the KSB. And so when you do this, you want to write out the dissolution of this, right? So calcium hydroxide, right, dissolves and forms Ca plus 2OH minus. And so if this is the saturation or the solubility of calcium hydroxide, that also equals the X values, right? So we're going to have first it's 0, 0, right? X, 2X, and then X, and then 2X, right? So X times 2X squared equals KSB, and we have the X value. So we just need to plug in the value and solve. So let's do that. Let me pull out the calculator. So 0.0102 times 2, 0.0102. And then this is going to be squared. And I got this as my KSP value. And that's choice E. Okay. For 19, which of the following systems is expected to have the greatest entropy? So they give you temperature and gas. And so this is again the same kind of idea. Gas always takes precedent over temperature. Okay. And so in this case, the greatest entropy would be choice C. It's in the gaseous state and it has the highest temperature. Argon also in the gaseous state, but it doesn't have the highest temperature. Okay. All right, 20 to 21. So 20 to 21, we have a solution and it has lactic acid and it has lactate. The first question, it's asking what's the change in pH when you add NaOH, and they gave these values here. And so the first thing we need to do is we need to figure out the first pH value. And so in order to do that, first we do pH is equal to pKa plus the base over acid. This is before any of the base is added. And we can do that because we have weak acid, its conjugate base, and the Ka value. So let's do that. So it's going to be negative 8 point or negative log of 8.205 times 10 to the negative 4. And then plus log of base, which is 2.75 divided by acid, 3.50. And so here we have an answer choice here. That's choice C. Or sorry, that's not choice C. What am I saying? That's the pH of the buffer, right? So 2.98. So C is not the answer, okay? And now we added a bunch of base. And so here is where you need to make sure you understand how the reaction works, right? If you're adding a strong base, it's going to react with the acid. And so it's going to react with the weak acid. And it's going to form the conjugate plus water. And so we already have, we need to figure out the moles. So the moles of the weak acid is going to be 3.5 times 2.5. So that's 8.75. And then the base is going to be 2.5 times 2.75. So that's 6.875. And then sodium hydroxide in this case is going to be 0.5 times 0.25. And that's 0.125. And so as you can see, sodium hydroxide runs out. So this is going to be 0. And we need to subtract 8.75 minus 0.125. So 0.125 is 8.625. And then this is going to be added to that. So 6.875 plus 0.125. So that's 7. And then after we do that, we need to add this to, we need to divide this by 3 liters because that's a total volume now. And so let's do that. So let's divide by 3. and this divided by 3. Okay, and then after we do that, now we do the same thing where we take the Henderson-Hasselbalch and we plug in values. So let's do that. So I just pulled up the original equation from my calculator. And so we do base, which is 2.33 divided by acid. So that's there. And I got a value of 2.99. Okay. Hello, what? Go back. How do I go back? Okay. So that's the pH after the NaOH is added. And so, yeah, we did the Henderson-Hasselbalch again. So I don't know if you can see this, but there's a lot of overlap with knowing how to do this question, and that there's only so many ways you could ask this question. But yeah, like if you understand how to set up things up, make sure you know like a base is going to react with an acid. So in this case, it's going to react with the weak acid. If it was a strong acid, it would react with the base. So that's choice 20. Okay. Any questions about that? All right. So now we're going to be talking about a different solution. So now they're talking about a solution of just sodium lactate, and they're asking to find the pH of that. And so sodium lactate is the conjugate base of lactic acid. And so in order to solve for this, you need to make sure you know NaA, right? Sodium lactate dissolves and forms Na plus A minus fully. And so A minus is going to react with H2O to form OH minus plus HA, which is lactic acid. And so this is going to be an ice chart. And this is similar to a lot of the times where we did this in class. So 2.75, 0, 0 plus x minus x, 2.75 minus x, x, x. All right. And we need to figure out the KB value, right? Because we're using it at base. And so it's going to be 1.0 times 10 to the negative 14. KW is divided by KA to find KB. So divide this by 8.25 times. Oh, I should put this in parentheses. To the negative 4. So this is the KB value, 1.21 times 10 to the negative 11. And we're equal to x squared over 2.7. So 2.75 minus x. Okay. So let me get my calculator out. Oh my goodness. Yikes. So x squared, 2.75 minus x. Okay. Then we put it into the calculator, we find the intersection point, and x is equal to 5.76 times 10 to the negative 6. And on your calculator, you can put x in and you get that value. So that's the hydroxide concentration. So 14 minus the negative log of x would give you the pH. And so the answer choice is D. Okay. Is there any questions regarding 21? All right. So 22, this is now a simple question, right? We got bromine. So bromine has, so oxygen is the negative 8 charge, potassium is the +1. So bromine has to be +7. So answer is here D. Okay. 23 to 25 is now dealing with the, balancing this stuff in, what's it called? It's balancing in acidic and basic mediums. And so, yeah, we're gonna have to do that for all 3 of these except for 25. So let's just do it, right? So let's first figure out the charges. So V is gonna have a +7 charge here. This is gonna be in -2, so -8. So this is +6. So each carbon is +3, so +6 in total. This is a -2, -4. So this is gonna be +4. And then this is a -6. So this has to be +4. Okay, so we can see that that carbon increases by um, yeah, carbon becomes more positive and V becomes more negative. Okay, so let's write this out. So I do it a different way. So V plus 7 yields V plus 4. And we see that 2 carbons, um, we could do something like this to make it a little bit more. V2 plus 6 yields carbon plus, what's it called? Carbon plus 4. Okay, so one thing that's first is you have to balance it by mass and charge. So there's a 2 over there. And then after that, we have to balance it by charge. And so if something becoming more negative, you're adding electrons. So there's going to be 3 electrons on the V side. And on the carbon side, there's a plus 6 charge on the left, and there's a plus 8 charge on the right. So there's going to be 2 electrons here. And so because of that, this needs to be multiplied by 2, and this needs to be multiplied by 3. And so the final formula you're going to get is 2V plus 7 plus 3C2 plus 6 yields 6C plus 4 plus 2V plus 4. And we can see if this is balanced. So plus 14 plus 18, this is 14. Or sorry, this is 24. And then this is 8. This looks pretty much balanced. Yeah. Yeah, 32 plus that. Okay, so after we do that, let's plug in these coefficients to the overall expression. So we have 2VO4 minus plus 3C2O4 minus 2 yields 2VO2 plus CO3 minus 2, and put a 6 in front of that. Okay. So now let me try to shrink some of this so I can get some room. I wish you could shrink on the exam, but unfortunately we haven't developed that kind of technology yet. Sadly, it would be nice. It'd be very convenient for these kind of questions, but I'm going to shrink here. Okay. So let me move this up a little bit. So this is the balance formula. So now we have to figure out which side has the least amount of oxygens. So the left side has 8 plus 12. So that's 20 in total. The right side has 4 plus 18, so 22. So there's going to be 2 waters on the right side. And on the right side, now we have to add the hydrogen. So they're going to be plus 4 on the right. And so to check this, we're going to, what's it called? Yeah, to check this, let's check the charge. So there's a -2 charge plus a -6 charge on the right. So overall, a -8 charge. On the right, there's a -12 charge plus 4, which is a -8 charge. So both sides have a -8 charge. And then everything's balanced by mass. So the first question it asks in the acidic formula, where's the H plus? The H plus here is going to be a product that has a coefficient of 4. Okay. And then when it's basic, C is supposed to have a product thing here. But when it's basic, now we have to add plus 4H minus on both sides. And you can see here that the waters will cancel out. So there's going to be 2H2O as a product because there's going to be 4 waters on the right. And then that cancels out with the 2H2O here on the reactant. So as a result, you're going to have choice C, where it appears as a product with a coefficient 2. What's the oxidizing agent? Oxidizing agent is the thing that's being reduced. And so in this case, it's VO4 minus. So that's choice A. So is there any questions regarding these 3 questions?
I had a question.
Yeah.
So if it asks what species is reduced in general, would it be the entire species as well as the individual ion?
It would be the compound in the reaction that is reduced. It's not the individual ion.
Okay.
Yeah. Okay, because technically speaking, the the like the whole compound is connected, like the oxygens are still connected to the V, right? So yeah, it would be the whole compound. Is there any other questions? Yeah, one thing I would say as well is the oxidizing agents and reducing agents are always reactants. So like that kind of like that should make you, I guess, like kind of get to a 50-50 kind of scenario. So make sure you are aware of that. All right, 26. 26 is the based off concept. So energy remains constant while entropy is always increasing. That's like a concept that we talked about. So the answer choice here would be choice C. Okay. 27. Which of the following occurs when HCl is added to HCN solution? So this is based off the common ion effect slash like Leishman-Tiller's principles, right? Where if you add H plus, you're going to shift it to the left. And so specifically for this, right, K's never change, okay? So K's are constants, so they never change unless temperature changes. So the answer choice has to be D, all right? But this also makes sense when we think about the concept, because when you add H plus, you're going to shift it to the left, producing more reactants. And percent dissociation is the H plus of equilibrium over the initial concentration of the like acid. So in this case, it would be like HCN, right? So if you shift it to the left, you're going to increase this denominator by a lot. So that's why the percent dissociation decreases. Okay, any questions about this whole page? Okay, so we have about 38 questions left. Or sorry, we have 10 questions left in total. So I'm gonna give you guys 10 minutes to try to do these questions, and then after that, I'm gonna go over it. So yeah, let me know how it goes. If you have any questions, let me know.
Wait, sorry, back to the other thing.
Yeah.
So if it said like which of the following things are reduced, right? And it had like VO4 minus as an answer choice, and it also had like V plus 7, and like you could pick both of them. Like, are you able to pick V plus 7? Because isn't it reduced to
Yeah,
V plus 4?
you could say V plus 7 is reduced, but I don't think he would give you an answer choice like that because that's a little unfair. Because technically V plus 7 is in VO4 minus, right?
Okay.
So like it would be the whole compound typically.
Okay.
But yeah, I'll give you guys 10 minutes to go through 28 to 38. And then we'll go over it at 3:30. Alrighty, guys. So I'm sorry for rushing you guys a little bit, but just trying to finish sooner than later. So you guys can study on your own, and I'll post this up there. But yeah, let's get started. So 28 gives you another list of compounds, and so we're again talking about intermolecular forces. In this case, which one's increasing in boiling points? So if you look here, C has dispersion forces, B has dispersion forces, and also a dipole. D has dispersion forces, but and a dipole, but it has more, so it would be D there, and then A would have the most intermolecular forces because it's hydrogen bonding. So choice A. B is the answer there. Which one's the most increasing? So as IMF increases, you increase in BP. Okay. 29. Which of the following statements is false? So let's see this, right? Yeah. Here, let's figure this out. Substance C is more soluble in nonpolar. That's true. Substance B is more soluble in water than substance A. That is also true. Substance B is expected to be less soluble in water than substance A. Less soluble. Yeah, that's also true. D, substance D is expected to be more soluble in water than substance B. So this is wrong. And then yeah, A is expected to be soluble in water. That makes sense. So the reason why B is the wrong one is because this involves like dissolves like. Right? So water is a small polar molecule. And so D is slightly bigger than water. And so it's not in comparison to B is a lot more similar to water than D. So the length like does matter in this case. So the size of the molecule and the type of intermolecular forces also matter. Okay. 30. Yeah, 30. Substance B is a colorless gas. Standard temperature, which of the following would decrease the solubility of the substance of B in a liquid solvent? So this is based off the rules for solubility of gas. So gases, if you want to decrease the solubility, you want to increase the pressure and decrease the temperature. So in order to decrease solubility of gas, it's going to be increased temp and decrease pressure. And the opposite is true if you want to increase the solubility of the gas. So B is the answer there. So any questions regarding 28 to 30? Okay. 31. 31 is we have a half reaction, and they give us some ideas and thoughts. So salt bridge, and one cell has aluminum nitrate with an aluminum nitrode, and the other one has a copper with a copper nitrate, or with a copper electrode. So we're trying to figure out the E cell for the spontaneous reaction. And so in order to do this, we have to refer to the reference table. And so yeah, we have copper, so Cu to like Cu plus, right? And then we also, or in order to find reduction potentials, right? It's going to be Cu plus to Cu and Al plus 3 to Al. They don't expect you to memorize these values, but you should be able to go at a table and try to figure this out. So aluminum would be right here. So that's negative 166. And copper is right here, so 0.52. And so in order to figure out which one's spontaneous, you have to figure out which one would be the most, would provide you with the positive value. So A and B are definitely wrong for sure. And so, yeah. Another way to figure this out without like needing to plug in values to figure this out is you could just figure, like if you know that the more negative E cell value you have, the more likely it's going to be the anode. So in this case, right, we see that copper has a 0.52 and aluminum has a negative 1.66. So the more negative or the lower value is going to be the anode. So that's how I would figure this out. So if I were to do the E cell, right, 0.52 minus negative 1.66, we're going to get a positive value, and that's going to be 2.18. So answer there is choice E. Okay, so you don't need to like plug in values to solve it. If you just know that like the more negative a value is, or the less, this lower number is probably going to be the anode, then you're going to be in the clear. Choice 32 or question 32. Yeah, 32 is what describes the spontaneous electrical process. So they're talking about the salt bridge and where it's going. And so we know that aluminum has to be the anode. So anything with the cathode and copper has to be the cathode. So whichever one is correct there. So like A would technically be right. B would be wrong because copper is not an anode. Aluminum is not the cathode. Copper is not the anode. And aluminum is not the cathode. So the answer has to be B. Also, like this is something that was really not really said much, but the negative anions of a salt bridge always go to the anode. So like let's say we have like KNO3, right? The negative anions go to the anode. So NO3 goes here, and the cathode gets the positive cations. So that's going to be K plus. And that's just because of the way the charges work. So yeah. Any questions regarding anything I just talked about for 31 to 32? Okay. All right, 33 to 34. So we have this reaction. And so they're asking which is true regarding this equilibrium. And so here we see this is a kinetic question. So the rate of the formation is equal to the rate of consumption. This is true because they're all equal ratios in the reaction. And then, yeah, the rate of consumption of, let's see, the concentration of HCO3 does not change over time. That's also true. Because at equilibrium, the products and reactants are constant at equilibrium. The concentrations are constant. 3, the rate of consumption of H3O plus is greater than Ca plus 2. That's also wrong. So yeah, the answer choice here would be D. Okay. Which of the following actions could cause the student to shift towards their products? And so equilibrium, you want to make sure you remember that adding a solid doesn't mean anything. So choice 1 is wrong. Decreasing the pH would increase hydronium content. This would increase H3O plus. And so it would shift the reaction to the right. So 2 is right. Removing calcium plus 2 would also work because that would shift it to the right. So choice D would be the right answer. Any questions regarding 33 and 34? Okay. So 35 to 36. Let's do this. So we have reaction mechanism, and they're asking what does the SO2 mean? I made a mistake in the first thing I sent out, and that SO2, that's supposed to be SO2. So if it's being produced and consumed later, it's going to be a intermediate. What is the rate law of the overall reaction? So in this case, we have SO2 Cl2, which is in the very slow step. So the answer choice would be A. Okay. Any questions regarding 35 and 36? Okay. 37 to 38. So we have this reaction here, and they're asking what's happening. So we know that the left side is the anode and the right side is the cathode. So zinc is getting oxidized to Zn plus 2. So which one's true? So silver is not the anode. This is not how the reduction works. Ag plus is getting reduced to Ag solid. Zinc is not getting reduced. Zinc is not getting oxidized at the cathode. So E is the only one that works. And then for 38, now we need to figure out what the reaction is. So this is going to be Zn to Zn plus 2, plus 2 electrons, right? And then Ag plus to Ag solid plus 1 electron on the right. So we need to multiply this by 2. So the final reaction you're going to get is Zn plus 2 Ag plus yields Vn plus 2 plus Ag, or plus 2 Ag. Okay, and so that answer choice there is choice E. And you can see that it works out as well. Everything's balanced in mass and charge. The other answer choices aren't balanced by mass and charge. So D is not balanced in charge. C is also not balanced in charge. B is balanced in mass and charge, but it's the wrong reaction. It's the other way around. And then A is not balanced in mass and charge. So that's why E is the right answer. Are there any other questions you guys have about anything that I went over? Okay. I guess I did an adequate job of explaining it. Please let me know if you guys have any further questions about anything regarding chem, regarding anything at all. Because yeah, we got today and then tomorrow morning. Just yeah, is there any like last minute questions, like not regarding the test? Or like a practice and that I went over?